right, welcome everybody. I hope you've had a great day so far, and I want to start by thanking the organizers for what's been a spectacular day and for inviting me to speak on an interesting topic about AI for a sustainable future. So that's what we'll be discussing for about the next 20 minutes. So Beyond Limits likes to think about AI as being an incredibly powerful tool for solving the toughest problems that face people and planet. And we really think about AI as augmenting a person's natural abilities and capabilities to solve problems that have never been able to be solved before. And lately, what we started to think about, a little bit about, is how AI can be applied to solve environmental problems, specifically those associated with climate change. Okay, next slide, please. So I think that most of you would acknowledge that the planet is under stress, and there's a number of environmental conditions that are causing great concerns to scientists and thought leaders. Just to mention a few of them, these aren't all of them. Air quality. 91% of the people on Earth do not live in the World Health Forum's, what they consider standard air quality control measures. Biodiversity. Since 1970, we've lost 60% of the biodiversity on our planet. This is something on the order of a massive extinction rates. Water. We estimate that we might be short by minus 40% by 2030. A shortfall of fresh water needed to support the global economy by 2030. The topic I'm going to talk about most today, though, is climate change. And really, the big issue there is that world greenhouse gases are at their highest levels, estimated to be at their highest levels in 3 million years. So really, I'm going to spend a little bit of time talking about the problem statement. What is climate change? Then I'm going to talk a little bit about what's caused the issue in the first place, to the best of our knowledge. And then I'll get to the topic that we're all really excited about today, is how can AI specifically be applied to address some of those problems. All right? So next slide, please. So if you look into a relatively short time frame of the Earth's history, the last 200 or 300 years, since the 1700s, you can see that there's been a slow but gradual increase in CO2 concentration, a gradual rise that increases in the near term, mostly after World War II, from 1950 on. You see a little bit of a steeper curve. But if you extend that time frame out quite a bit further, looking at a broader portion of the Earth's evolution. So next slide, please. If you look on a much grander time frame, going back, for example, 800,000 years, you can see that while over the course of Earth's evolution, you've seen parts per million of CO2 concentration in the atmosphere fluctuating from well below 200 to mostly back up to about 250. And a couple of times it's even hit 300 parts per million, all right? But that's been relatively rare. What has certainly been rare is what happened in 2013, where we hit 400 parts per million of CO2 in the atmosphere, all right? And what you can see is that there's been a very, very sharp increase in atmospheric carbon in the very near time frame. So what's happened? What changed at that point that hadn't happened for hundreds of thousands of years prior, all right? Next slide, please. Well, it was the coal era, all right? For hundreds of thousands of years, human beings produced energy and heat by burning trees or moss or peat moss or animal dung. And that's what was primarily used until about the early 1800s, 1850, where they started using coal, all right? And that's gradually increased until we started using other fossil fuels in addition to coal. You're familiar with all of these: crude oil, natural gas, all right? Next slide, please. And so what are we using? That's been the big change that's happened in the last couple of hundred years. So what are we using fossil fuels primarily for today? Well, almost all of our fossil fuel use goes into electricity and transportation, all right? About 20 to 30% in electricity and transportation each. And that, of course, means, by definition, that 20 to 30% of our greenhouse gases are associated with electricity, and transportation. It doesn't mean that CO2 isn't coming from other sources. There's also industrial processes and agriculture. But in this talk, I'm just going to focus on energy and mobility, or electricity and transportation, because if you can move the needles on those two activity sets, you can get a huge impact in our carbon footprint. All right? So that's what we're going to start talking about today. Next slide, please. All right. So the acknowledgement of climate change and the intensity of CO2 concentration in the atmosphere, especially when it hit over 400 parts per million in 2013, has caused people to sit up and take a look. And it's been really disruptive for the transportation and energy industries, all right? This has been quite a disruptive activity set. And I just want to give you a few examples of some headlines that are happening out in the world that show the changes associated with that acknowledgement of the disruption in those activity sets. So for example, Britain to ban the sale of all diesel and petrol cars and vans from 2040. All right, next slide. California sets a goal of 100% clean energy by 2045. Now, California isn't a country, but it is the 5th largest economy in the world, and so people do take notice of what California does. And as an example, just recently in the US, 9 governors have run their campaigns on a 100% clean energy agenda. The next slide, please. Scotland to become a net zero society by 2045. All right, this is 5 years earlier than even what the UK has set their goals and standards for. Next slide. Saudi Arabia has announced their vision for solar power and renewables. They want renewables to become a much bigger part of their energy mix. They think it's good for the economy. It creates jobs. They've announced that they want about 3.5 gigawatts by 2020, 9.5 gigawatts by 2023. And they've already announced 2 wind projects and 1 solar power project. Next slide. UAE is building, to our knowledge, the largest scale single solar power facility in the world. And this is a first of its kind. It's actually using 2 technology, PV, as well as concentrated solar power, and really a first of its kind project that's going to probably set the standard for how other projects are built in future. It's really exciting. The next slide, please. So it's not just governments and cities that are making changes and setting these standards, legislation, policy. The markets are responding to the same activity set. In 2019, 55 coal plants went out of business, and for the first time in the US, renewables made up more of our energy portfolio than coal. So right now in 2019, about 22% is coming from renewables, 20% coming from coal. This is a huge market change and shift. It's not just the markets that are responding, and cities and governments and countries, it's also companies. Companies are responding to how not only legislation that they think is coming, but also what they think customers are going to eventually demand. For example, next slide, Google. So Google has been carbon neutral since 2007. And right now they're the largest corporate buyer of renewable energy in the world. All right, that's pretty amazing. Next slide, please. Transportation, I've already told you that transportation is responsible for 20 to 30% of both fossil fuel use as well as greenhouse gas emissions. So the automobile industry has been making massive changes in how they plan to be operating in the future. Porsche has announced 50% electric by 2020, Volvo 50% fully electric by 2025. Next slide, please. Daimler has stopped development of the internal combustion engine entirely. They're going to fully focus on the development of electric cars. Next slide, please. Amazon, another brand name that we all know, has announced that they're going to buy 100,000 electric delivery vans, again, focusing on decreasing their own carbon footprint. All right, next up. So where there's big problems, Beyond Limits believes that there's really big opportunities. All right, and really we need to focus on 3 ways to help solve this problem. All right, the first is, and I don't want to discount the importance of this, it's the decarbonization of our current activity sets. So I've told you good news and bad news. I've told you that 20% of renewables make up our portfolio right now? Well, it means that the other almost 80% is still fossil fuel based. That's going to be a part of our energy portfolio for a very long time, make no mistake. So we need to manage it, and we need to make that portfolio lower carbon, all right? So we need to target our current activity sets. How do we decrease the carbon footprint of our traditional activity sets? And then, of course, the second thing that we want to target with AI is renewables. And the third that I'll touch on briefly is things that I call carbon negative, things that can actually take CO2 out of the atmosphere, referred to as carbon sequestration or even carbon capture and reuse, all right? So I briefly want to talk about those three topics. What I'll also say is, these are really important topics for us to consider and how to manage as a society, because this is the way people, cook their food and warm their houses and drive to work. So, our fossil fuel portfolio cannot just disappear. We have to just learn how to manage it as we're moving towards that renewable future. All right, so next slide, please. Many of you probably heard Linwood Farr talk about AI at work in power generation and the concept of the cognitive power plant this morning. If you go to the next slide, you also heard AJ Abdullah talk about AI at work in refining and how Beyond Limits is involved in both of these processes. The concept here is, and you heard both of them talk about less waste, greater efficiency, more productivity, and therefore more profits. But I want to add one more thing to that mix. Anytime you're talking about less waste and a better utilization of resources, you're also talking about lowering your carbon footprint. And I believe this is going to be something that comes more and more into our mindset, because there will be legislation, there will be carbon targets for refineries, for power plants, where if we get in front of it and we're able to add a differentiating aspect where we can say this is our carbon footprint, and we can add an AI capability, and optimize for carbon or output or profits or speed, we can choose what we're optimizing for. That's an incredible differentiating aspect, and I think it's something we need to get in front of. So, and we also see not only can you use this in the concept of a power plant or a refinery, but other manufacturing processes as well. If you go to the next slide, AI at work in logistics and supply chains. This is a huge, low-hanging fruit target for AI and how it can really have an impact. So if you think about moving commodities from point A to point B, it actually can be a really complex process, right? Are you moving it on ships, planes, trucks, all three? What are you trying to optimize? Is it fuel efficiency? Is it the route? Is it speed? Is it something you need to get there really fast? Are you bundling? So you're making the most of the space and bundling different commodities in a single route, for example. Or are you optimizing for carbon? Once we add AI to these processes where we can optimize and pull those levers, again, carbon is something that can come into the mix where we can optimize fuel efficiency, we can optimize routes, we can make sure that we're optimizing the commodities that we're bundling in these particular aspects of transportation, and again, really decrease the carbon impact of logistics and supply chain. If you go to the next example, AI at work and transportation. So we all know that AI is absolutely going to have a role to play in autonomy. But I actually want to talk about AI in the context of autonomy, in the context of carbon. And again, it has to do with efficiencies again, offering eco options, ride sharing, platooning. Platooning is when you have trucks that are linked in such a way that one truck is using the backdraft of the truck in front of it to increase its fuel efficiency. All of these things that AI brings and are required for AI also reduces the carbon footprint of these activity sets. One really interesting statistic is that 30% of jet fuel is wasted in what I would call non-productive activity. 30% is wasted on the ground, taxiing or waiting to take off, or at the gate. 30% not even used to move us through the air. That's a huge piece of waste that AI should be able to help us with if you add AI to logistics and supply chain and some of these transportation problems. Next slide. So AI, of course, has a role in solar and wind. So a lot of people just think of solar and wind right off the bat as being carbon neutral. that actually isn't true, right? While they are clean energy, the same logistics and supply chain problems apply to them. There is a carbon cost to get materials to a location in the logistics and supply chain routes. And the materials themselves, the materials that make up solar and wind farms are not green, all right? And then the service and maintenance of those farms also have a carbon impact. So that's where AI can play in renewables. And again, as we move our portfolio more in that direction, optimizing, for example, I think a big area where AI will play is in robotics, looking at service and maintenance of these farms, as well as in the logistics and supply chains, as well as in things like sun tracking systems to make sure you're optimizing the solar radiation that you're capturing. So AI, again, already being applied to solar and wind farms. Wind farms produce an incredible amount of data that people are using to do all sorts of things from an AI perspective. And this is an area that Beyond Limits actually is hoping to get into very soon. So if you go to the last slide here for this section, this isn't the last slide in the talk yet. This is a really fun one that I wanted to end on. And this is more about that carbon negative opportunity that I'm talking to you about. I've really only talked about one side of the equation, right? So the end of the equation that we've been talking about is that fossil fuels are releasing more CO2 in the atmosphere than ever before. But also deforestation is a huge issue. Trees absorb carbon dioxide. They're great at sequestering carbon dioxide. And we are cutting down something like 28 billion trees every year. So we're cutting down our natural carbon sink for CO2. And we've got to do something about that. Now this audience, since we're talking about tech, might think that growing trees is a really low-tech way to deal and to actually sequester carbon. But it's actually a really important part of the solution, and it will be a really important part of the mix on how to control our atmospheric CO2. This company has been getting a lot of press lately, Biocarbon Engineering, because they're adding AI to this very interesting solution. Not only are they using AI to actually plan where they're going to reforest these deforested areas, but they're actually using AI AI-controlled drones to reforest huge swaths of land. They estimate they can plant about 1 billion trees per year. 1 billion trees can sequester about 9 million tons of CO2. So that's a huge impact right there. Right now they're doing trials in Australia and the UK, but we'll all keep an eye on this exciting company that's using AI in a really unique and exciting way. So next slide, please. So how does the future look? It's not all doom and gloom. The momentum is definitely in the right direction. You've seen what cities and governments, how the markets are responding, even companies. We're absolutely headed in the right direction. But we need to do more. And in order to do more and really see a step change in this area of activity, we need AI. AI is going to help us get there. So if you go to the next slide, and you look at applying AI to sustainable and environmental problems. PricewaterhouseCoopers has done a pretty interesting analysis on the value that AI could bring us as a society. If you start just with energy and greenhouse gas emissions, applying AI, they estimate that it could reduce greenhouse gas emissions by more than 2%. If you add transport to that mix, you can see a further reduction of about 1.7%. GDP can grow, adding to all environmental applications, up to 4.4%. And perhaps most importantly, I've heard jobs being talked about a lot at this conference, and there is this fear that AI will take away jobs. Beyond Limits doesn't hold that position at all. Beyond Limits' attitude is AI will absolutely deliver more jobs in the future, and AI applied to the environment and sustainability is no exception. They estimate 38 million new jobs associated with AI and sustainability in the future. So I know there are a lot of young people in the audience thinking about careers in AI. That's why many of you are here. And what I would say is I can't quite imagine a more thrilling career where we need talent, we need scientists and technologists thinking about AI and how it applies to some of these really big, massive environmental problems facing our people and planet. So something for you to think about. I'll end on one other note that AJ asked me to announce while I was up here today. I had an amazing women in tech panel where I was speaking to lots of young women about their future and their future in tech and what they wanted to do. And we discovered that 60% of the attendees at this conference are women. Beyond Limits is committed to diversity. We hire people from different nationalities, religions, cultures, gender, you name it. It's very important to us. And we did want to make sure while I was standing up here that we let people know that internship is really important to us, and we fully expect diversity in our internships well, and one of those will go to a woman. So with that, I'll finish up. Thank you.